like gravitational force. Okay, and that's what the negative 16 is coming from. One is meters per second, which you're more likely to use in science class, and the other one is feet per second, which you're more likely to use in math class. Okay, so they're really the same equation, just in different units. And we're basically going to work with that bottom equation because, again, most of the time in math class, we work in the units that we use here in the United States. So we're working with the negative 16 feet per second. And the big difference today is we're going to be looking at projectile motion in terms of parametric equations. So I'm going to take this, which I would consider a rectangular equation, and I'm going to change it into parametric equations. So here are your formulas basically for parametric equations of projectile motion. Do either of those seem like the ones from physics? I hate to even ask at this point. I'm so confused. But maybe?
No, but think about what it's...
None of ours have the angles in it. Here, these are our equations.
No, but you see, it's I don't think that's velocity initial. I think that's just combined velocity. And then the cosine theta would give you either the horizontal or vertical aspect. So basically, it's taking a step
about like
back.
vectors, right?
Yeah, it's what that is the acceleration times time squared plus initial velocity times the sine of whatever the angle is.
Yeah.
Times time plus you see it. That's just this is the vertical movement.
I'll let the physics people kind of figure it out. So we have to have two equations now instead of one equation. The x equation, x equals v sub 0 times cosine theta times time. This is for horizontal distance as a function of time. So it's telling us how far the projectile is from us horizontally. And then the y equals negative 16t squared plus v sub 0 sine theta times t plus h of 0. This is giving us our basically vertical height of the projectile as a function of time.
So v0 is like the initial velocity.
Yes. Let's write that down. V sub 0 is initial velocity, which in our work, like, it'll just be stated, like, this was, like, launched into the air with an initial velocity of, like, whatever that may be. Does anybody remember what h sub 0 is? Your initial height, right? So sometimes, if I'm throwing an object, the initial height would be wherever I release it in the air. What if you're on the ground? What would your initial height be? 0. Okay, so sometimes you could have a 0 there or not have a plus h sub 0. That would be fine. Just to kind of clarify, theta, of course, is the angle at which the projectile is released, and then t is, of course, representing time. Okay, x is our horizontal distance, y is our vertical height. So the nice thing is, this is like our standard set of equations in parametrics for projectiles. Okay. And what you're really going to be doing is like reading the problems and really thinking about, like, okay, what are the pieces that I'm provided with? Do they fit in for x equation or y equation? What would I be able to solve for? If I could solve for something, would that be helpful to me to answer another question? So there's like lots of questions that can be asked about the same problem. Okay, just kind of phrasing it differently or looking at a different piece. So we're going to work with the same problem as our example. I would definitely write something down for this. So kind of jot down what you like for it, and then we're going to look at several questions that deal with the same problem. So this reads, an archer releases an arrow from a bow at a point 5 feet above the ground. The arrow leaves the bow at an angle of 15 degrees with the ground and an initial speed of 225 feet per second. write a set of parametric equations to model the path of the arrow. So remember, parametric equations, that means we have two equations, one for x, one for y. Both equations will be written in terms of our parameter, which in this case will be time. And we're just going to plug in to those parametric equations that we had on the previous slide. So x is equal to v sub 0 times cosine theta. What is my v sub 0? The 225 feet per second. And what is my theta? 15 degrees. So we're going to say x equals 225 times the cosine of 15 degrees times t. And I would say this, leave it in that notation. Okay? And like we were kind of talking about when we were looking at the equations, this 225 cosine 15, that should seem kind of familiar to you from our work with vectors, right? That's like the horizontal component of the vector. And so it goes along with x, which deals with our horizontal distance. And then we're going to write an equation for y using the same bits of information. So we're going to start negative 16t squared plus, this time it's going to be not the horizontal component, but the vertical component of our force. So sine 15 degrees times t. And our initial height is 5 feet. So that's our h sub 0, so plus 5. Now, another thing that I like to do for problems like this is sort of sketch out just an image of what is happening so that as I answer further questions, if I'm having trouble like putting that into context, a visual can be very helpful for that. So I'm going to draw my archer, releasing an arrow, and that looks something like this. This is very easy. We'll go up. And then we'll come down to the ground. And so now I can ask some follow-up questions. So my first question to you is, what is the max height of the arrow, and when does it reach its max height? So one thing you could do when you read this question is really think about, like, what sort of things in these parametric equations am I asking about? If I'm asking about a max height of the arrow, which equation is going to involve height? Y. And what part of that equation represents the actual height of the arrow? The value of y, right? So I'd really like to know, when I'm doing this, I'm trying to find a y value that represents the maximum that it could be. When I ask the question, when, what am I trying to find? T, time. So that could be something that if you're struggling to make sense of like where to start your question, identifying like which parts you might be looking for. So like for finding the max height, I'm obviously going to be working with the second equation. To find time, I have to think about like, would I want to find time in the first equation or would I want to find time in the second equation? Okay, so ideas on how we might be able to answer this question. Okay, solve for t first, so find out when it reaches its max height, because if you can find out when it reaches its max height, to find max height, all you have to do is plug in the time. Okay. So maybe solve for the time first. And how would we find the max height? Can you picture where the max height is in the picture? Yes, right in the middle area, right? What do we call that in terms of the graph? Did you say midpoint? It's very close to the middle. I'm not confident that it actually is in the middle of this graph because remember, I released the arrow at 5 feet above the ground. So that's symmetric over there, and I'm actually going a little bit further. So I don't know that's in the middle, but the picture is what shape? parabola. What do you call that point? The vertex. Okay. So to kind of help you out, we're going to be focused, you guys said, on the y equation for right now, because we're dealing with the height. So we're looking at y. And I'm going to write over here my little hint to you. This, to me, looks like what we called in Algebra 2 the standard form for a quadratic function, y equals ax squared plus bx plus c. So I can easily identify in my parametric equation, a is -16, b is 225 sine 15, and c is 5. So my big question to you is, do you remember how to find the point we labeled, the vertex, using a's, b's, and c's? So I'm going to let you brainstorm real quickly with your tables. Do you remember anything from y equals ax squared plus bx plus c that could be helpful? So you think about a's, b's, and c's. Just go throw out some ideas, talk about what they mean, see what you can get. In that x one? Yes, there should be a t. Oh, there's not a t, it's a 5. Plus 5.
Whatever that is.
The t is on there's a t on the side. So you have a t squared, you have a t, and then you have a 1. So there's a t behind base of 0. Like it outside. I mean, they're all getting multiplied, so it doesn't really matter. I put it in the base of 0 sine theta. Okay, were there any brilliant ideas out there? Ideas? Oh, yeah, we could complete the square. Do you think that's easy to do with a b value of 225 sine 15? Probably not. So that's what we like, and we're gonna go back to that completing the square when we do our next chapter, chapter 10a, with conic sections. We're gonna go back and we're gonna do that a lot. So that's something to kind of hold there in the back of your mind and keep it ready to come up for our next chapter. But because we're working with this value for b, that's always like your initial velocity times the sine of the angle, that's not going to be an easy thing for us to complete the square. It's probably always a decimal value, right? And so for us to be able to complete the square, we need to be like able to factor out -16 and do all that work to complete the square. There's probably an easier method. Anybody, any groups talk about that easier method? Any other ideas? With A's, B's, and C's? What's that? Oh, do you remember something called the quadratic formula? Yes. Do you remember the song? Did you sing the song? Try to sing it really quickly. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. I'm a little bit tongue deaf, so that's Puck Goes to Weasel. In case you didn't know. Your math teachers have done you a disservice if you did not sing the quadratic formula. I know Nick has sung the quadratic formula. I know Ethan has sung the quadratic formula. Faith, anybody who had me last year would definitely sung the quadratic formula. What does the quadratic formula find? It finds x, and Jordan is saying in the parametrics it would be solving for t, so it's really t equals now, right? But what t is it finding? What does the quadratic formula find for you in the picture? Does it find the maximum?
No,
It finds the 0. So if you wanted to know when the arrow hit the ground, and we will want to know this on my next slide, okay, then you could use the quadratic formula. I also heard some groups talking about factoring, and I was unsure if you were talking about factoring for like completing the square, you have to factor out -16, or if you're talking about like factoring the trinomial. If you could factor that, that's another way to find your zeros, which would be a place where your arrow hit the ground. Now, I'd say in projectile motion, you're not going to want to try to factor because your middle term is a initial velocity sine theta, so that's not something that we can really factor. Okay, so we're probably going to stick with quadratic formulas. Thank you very much. Do you remember any other formulas with B, A? Yes, but that has nothing to do with y equals ax squared plus bx plus c. Oh, when I write this down,
Well, actually,
Something with like the cosine A.
David, no.
The long
if we just draw straight lines.
David, no.
No.
No, David, no. Not doing
I
that.
don't remember if that's right.
you've seen it though.
Not doing it.
Opposite b over 2a. It's for finding the x-coordinate of your vertex. You should write this down. You should write this down. X equals the opposite of b over 2a. And remember how we were working with Emily with the quadratic formula and we said x equals the opposite of b, blah, 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 blah. But we're going to change it really, it's t equals. So in this particular work, we would maybe cross this out and say this is really t equals the opposite of b over 2a. This point that is the vertex right here, its x value is the opposite of b over 2a if you're working with something in standard form, y equals ax squared plus bx plus c. And so to get your y value, it's just like in function notation, f of the opposite of b over 2a. Don't be so concerned with that. That's just plugging that number in, right, and getting your y value. But that's how you get the x-coordinate of your vertex when it's y equals ax squared plus bx plus c. Another method we have is the completing of the square and writing it in our what we called new standard form in semester 1 with the h and the k. But we can't really do that with this particular middle term.
What does the y value stand for?
F of opposite of b over 2a. So this is just function notation saying the y value when x is the opposite of b over 2a. Like you would just plug it in. Okay, so don't really worry so much about that. Okay, so now we can find the time. When the arrow is at its max height, we're going to do the opposite of b, which is negative 225 sine 15 degrees, divided by 2 times a, which a is always going to be negative 16 for us, so I'm dividing by negative 32. Okay. Type that into your calculators. And I think I get something like 1.820 seconds. Does that seem right? Okay, so when does it reach its max height? 1.82 seconds later, after its launch. What is its max height? How will we find that? Plug that in for t in the equation for y, right? Negative 16 times 1.820 squared plus 225 sine 15 times 1.820 plus 5. If you have the 1.819, whatever it is, already in your calculator, you could remember, use your answer button for a more exact value. I think I get something like 57.99. Does that seem right to anybody? Can I get somebody to second that? Allie got it? Okay, if you did not get that, I want you to look,
Check if your graphs are still in polar form and radian mode.
okay, so which mode do we really have to be careful with? What mode do we want to be in? Degrees. Okay, for the function polar parametric section, that doesn't really affect your calculations. When we change that mode from function to polar, or you might notice there's a PAR for parametric, that only affects your graphs. So like when you go to your y equals, it's either y equals, r equals, or if you change it to parametric, in this chapter you'd see x equals and y equals, so you can put in two equations for one graph. So you don't really have to change it out of polar mode. What you really need to do is change it back to degrees. So change it to degrees and then try again. Okay? And let me know if you're not getting 57.99b. The other thing I would do is look very carefully at your numbers. Did you type everything in correctly? If you're getting a different number. If you got 52, did you forget to add 5? That's an issue. What if I took that t and I plugged it in for x? What would I be finding if I plugged it into the other equation? How far it is when it reaches its max height, right? So like what's its horizontal distance from you when it reaches its max height? Okay, if you want the actual max height, you have to plug it back into the y equals, the vertical height. Are we okay over here with our 57.99?
So the feet is the max height?
Yes. This is the time it reaches its max height. This is what its max height actually is. Okay. So remember, y represents a vertical height. Okay, now I'm going to ask a follow-up question. My next question, same scenario, so you don't have to rewrite anything. How long will the arrow be in the air?
When she just multiplied 2 times.
Set y.
Okay, now I did hear one statement that I want to address. Could you just take the time we just found
No.
and multiply it by 2?
No.
Why not?
Because we've already noticed that it's a little bit more than double because it goes past 2.
Okay, remember, it's 5 feet, then it reaches its max height, and then by symmetry, okay, if we doubled the 1.82, we'd only be to this point. Now think about it. Is it going to take very long for your arrow to fall the extra 5 feet? No. So if you thought about what 1.82 times 2 was, approximately 3.64, right? Our answer that we get for this should be pretty close to 3.64. So that would be a nice way to check if your answer is reasonable. But we need to think about, because we will of course want an exact value, how we might be able to find that exact value when it hits the ground, and you would tell me set y equal to 0, okay, because y equals 0 represents a height of 0, and if your height is 0, you're on the ground, okay, so that's like that discussion we had with Emily with the quadratic formula, right? If our height is 0, we're on the ground, so we would use the quadratic formula. So I'm going to 0 equals negative 16t squared plus 225 sine 15 t plus 5, and then I'm plugging that into my quadratic formula. T equals the opposite of b, so 225 sine 15 plus or minus the square root of b squared minus 4 times a times c, all divided by 2a, which I just usually write negative 32. That's what it's always going to be in these problems. Now, if you plan to type this all into your calculator at once, if you don't have that math print where you can see things like as fractions and write stuff actually underneath a radical, you're probably going to have to be really, really careful with your decimals, or sorry, with your parentheses, so that you get everything correct. I'll pull up my calculator really quickly, and I'll do my numerator in my calculator where I have to like use parentheses. So I'm going to pull up my calculator over here. Put my marker down. I'm going to check my mode, make sure I'm in degree here. Oops, I entered it. And then I'm going to do my numerator. So I'm just going to do negative 225 sine 15. And that one, the parentheses isn't necessary. Okay, but if I put parentheses around it, then I need 2 parentheses to close my 15, to close my b. And then I'm going to do plus, and I'm going to pull up my square root. Oh no, I have it in math print. I'm not going to use my parentheses this time. Negative 225 sine 15, and then I'm going to do plus the square root of, and see, mine's just going to give me a parentheses. So now I need a new parentheses to do the 225 sine 15 squared. So I'm going to do an open parentheses for 225 sine 15. I got to close the parentheses for the sine, close the parentheses for b, so I have double parentheses right there, square it, and then I do minus 4 times negative 16 times 5, and then it won't make a difference if I don't close it, but I would really have a double parentheses because I'd be closing all the things underneath my radical. So you have to be really careful. You need double parentheses to start, and you got to close it when you want to square your v sub 0 sine theta. And I get something like 2.68. Now, if I divide that by negative 32, what kind of answer am I going to get for t? A negative number, is that the number that we want? No. So I'll be able to just second enter, and I want to go back up here to the opposite of b. Instead of plus, I want to do minus. So I'm going to change that to a minus. And that gives me negative 119.15. That's the number that I want to divide by negative 32, because a negative over a negative is going to give me a positive. Okay, so you can kind of like, you don't have to solve for both. You want the one that's going to give you a negative. Okay. So divide by negative 32. And I get 3.72, which I know, Nick said 3.7. Are we really, really close? Are we really, really close to that double time? Yeah, it just takes like a little bit extra for it to actually hit the ground from that high speed. But I'm going to want to see your mathematical work, right? Not your guessing, not your checking, those kinds of things. I'm going to want to see your math. You're a mathematician. Do the math. Okay, what horizontal distance does the arrow travel before it hits the ground? How would you answer this question? There's a new question on the board. You seem distracted. What horizontal distance does the arrow travel before it hits the ground? How would you answer that? Plug t into the x. This is when the arrow hits the ground. This question is now asking about a horizontal distance, so we know that has to do with x. So we'd like to do x equals, what do we have? 225 cosine 15, and then multiply it by the time it hits the ground, which we have just solved using the quadratic formula. And I think that comes out to 808. Did you do cosine or sine?
Oh, yes.
Okay. If you're doing horizontal, it should be cosine. Are those the only questions that I'm going to ask you on this worksheet? No. I'm going to ask all different kinds of questions. So, listen, I'm not done. Jacob, David, I'm not done. Thank you. I'd like your attention. And if not your attention, at least allow others to listen. This is the first question on the worksheet. A baseball is hit when it's 3 feet above the ground and leaves the bat with initial velocity of 150 feet per second. The angle that the ball leaves the bat is 20 degrees from the horizontal and goes towards a 20-foot fence 400 feet away from home plate. Will the hit be a home run? What would make the hit be a home run? If it goes over the fence. So if the height, the vertical height of the ball is more than 20 when it gets to the fence, then it would be a home run. If the vertical height of the ball is less than 20 when it gets to the fence, then it would not be a home run. So before you can answer that question, you really need to know, when does the ball reach the fence? How far away is the fence? 400 feet. So you could put 400 in for x in your horizontal equation and solve for your t. That's when the ball reaches the fence. And then you could take that t and you could plug it into your y equation to find what is the height of the ball when it reaches the fence. Does that make sense? And if it's more than 20, you say home run. If it's less than 20, no home run. So you might have to think about the question that's being asked of you, and there could be lots of different ways to phrase that question and have you try to solve it. Okay? But that's just kind of an example of something that could be different. So really think about what things you would need to know in order to be able to solve it. Jacob, will you hit the lights up for me?